Excited to have you on today. I'm excited to get into the nuts and bolts of mitochondrial function, which I think is everyone's secretly their favorite topic to talk about because there's
Hmm.
so much that ties into there. But before we get into that, on the master classes, I just have everyone kind of introduce themselves because I don't know that this audience has gotten to know you on a personal level yet. I don't know if they want to, maybe that's up to you. But I would like to give you a few minutes here just to kind of introduce yourself, what it is you're working towards, why we're talking about mitochondrial function, then we'll get into it if that's cool with you.
Sure. Do you want like my whole sort of personal story of why I'm doing this, or a
Yeah,
much
yeah,
briefer version? Okay.
let's go with
So
it.
I'll give you a brief version. So health science has been my passion since I was a little kid, since I was about 12 years old. This has been sort of a lifelong passion, obsession for me. Um, but for most of that time, up until my mid 20s, it was very focused on optimizing athletic performance and body composition. I was interested in bodybuilding, muscle gain, fat loss, having ripped abs and big biceps and big pecs, and and being a better athlete. I was a martial artist and I was a soccer player growing up, and that was kind of my world for a very long time, and I went very deep in it, and I think I was uniquely gifted in that regard, or at least uniquely obsessed. I mean, I was reading college level textbooks, physiology, nutrition textbooks by the time I was 14, 15 years old. um, and that's just what I wanted to do in my spare time. um, when I was in my mid 20s, something happened that kind of changed my course. I got very sick with mononucleosis from Epstein-Barr virus, and um, I was extremely ill for about 6 weeks from it. I had two big golf balls in the back of my throat of pus, and extreme swelling and inflammation there, to the point where I couldn't eat food for several weeks. So I lost like 40 pounds in that span of time. But the worst part was that for about a year following that, I was severely fatigued, and that really rocked my world, because I was always a healthy guy. I was always fit. I was always an athlete. I always had an abundance of energy, and all of a sudden now I didn't have any energy. And I had a girlfriend. I was working on a job. I was working on a fish farm doing hard manual labor at the time, and I was also a student, and I was transitioning from college to graduate school. And at that time, when I got sick, and for months and months and months, I was severely fatigued physically and mentally, I basically just watched all sort of my hopes and dreams fade away. My aspirations, my uh, career aspirations, my ability to spend time with my girlfriend, with my friends, to play sports, to do my job, all of it fell apart. And that was sort of the catalyst for me becoming really interested in this whole area of fatigue and energy. And then as I explored more deeply, and I went to see conventional doctors, who, generally speaking, have almost nothing to offer people with chronic fatigue, and we can talk specifics and data around that if you'd like. And I went to see lots of alternative and functional medicine practitioners, natural health practitioners, who almost universally diagnosed me with adrenal fatigue, and who, even after testing my adrenal function and cortisol levels and seeing that it was normal, still tried to diagnose me with adrenal fatigue. Um, and and then following that, I became very deeply interested in that topic. I spent literally a full year of my life almost doing nothing except exploring the literature around adrenal fatigue, uh, uh, around, I should say, adrenal function and cortisol levels, HPA axis function more broadly, and chronic fatigue, to see what the actual science says about that relationship. Something that I could boil down into a few minutes of conversation. I wish I didn't have to spend a year of my life to do that, but
Hindsight's always 2020.
yeah. At this point, I'm for sure one of the most well-read people on the planet on that body of scientific literature. I mean, I can't imagine there's more than a handful of people on this planet that have spent more time immersed in that scientific literature. Um, Ultimately, really discovering that adrenal fatigue is mostly nonsense. that there is very little evidence to suggest that adrenal abnormalities or HPA axis abnormalities are a significant factor for most people who have chronic fatigue. And after all of that, and this is again something we can talk more in depth about. I'm giving a very surface level description now, but after all of that, basically I realized, hey, I've got this problem of chronic fatigue. It sucks. It really ruins your life. And I mean, you really, it detracts from everything that you want to do in life in a massive way. And it just really steals your life away from you because you can't do what you want to do with your life mentally or physically. And that both conventional and natural health doctors have very little to offer. They haven't got this story of chronic fatigue and human energy regulation figured out. So that was really the big catalyst for me to become interested in this area. And that's what I've been doing for the last decade.
That's awesome. I mean, you and I have had many a conversation surrounding everything under the sun when it comes to topics around health and misconceptions and things that could be philosophically looked at in a different way. And what's so cool about this conversation today, besides my own interest in it, after all the conversations we've had up until this point, is we just had 2 episodes where we focus on the cell danger response, and then the cell danger response that dovetailed into detox and how that kind of gets messed up when people are trying to force detox when they're ill. So how would you dovetail how you want to frame mitochondrial function? And then can we introduce the cell danger response in that to start the meat of today's topic?
Totally. So I'll kind of segue from where I left off in the personal story. So at that point where I decided, hey, I'm going to go explore this topic of energy, I had no idea where to begin because nobody had presented any kind of coherent synthesis scientific framework of human energy regulation at that point. So I basically just started digging into certain topics that I knew something about and said, oh, well, certainly sleep and circadian rhythm. I know a few things about that. And this was a long time ago. This was when I was still in my 20s, still very much a fitness and bodybuilding sort of fanatic, before circadian rhythm was popular to talk about. And I started exploring, I basically said, well, we know that if you've got a crappy night of sleep or you travel into a different time zone, that disrupts your energy level. So what are the mechanisms there of how circadian rhythm ties into energy and energy regulation? And I started exploring all these neurotransmitter and hormonal mediated mechanisms. What is it doing in terms of biochemistry and, at the cellular level and all these kinds of things. And I developed, all these different mechanisms of how that interaction takes place. And then I started exploring, okay, well, nutrition is certainly linked to poor energy levels. If you eat a crappy diet, certainly that's going to impact on your energy, but what are the mechanisms of how that works? And so I started digging into that to build out sort of an understanding of that. What about, exercise? And I started digging into that. What about toxin exposure or environmental toxicants? What about hormetic stress? And all these layers. And I went into one layer at a time and explored it very deeply. And that was like 3 years of my life doing that. And at the end of all of that, I was left with basically a list of like 150 different mechanisms that in one way or another impact on energy regulation or on energy levels, I should say. But what I didn't have was any kind of coherent framework to understand what is really regulating the system. Because if you think of a car, and I know you're a car fanatic, Roland, so you'll appreciate this analogy. We can look at different parts of a car and say that they are necessary for that car to function. So like we can go in and look at the spark plugs and be like, well, if we pull out the spark plugs, the car doesn't seem to work very well. And then so that the spark plugs must be the key thing that's causing this car to run, right? Or we could pull out the engine block and the car won't run, or we could pull out the crankshafts or the pistons and any number of other parts in there. And if you remove those parts, the car won't work. So and yet none of those things, none of those dozens of parts that we could remove to make the car not function. So we know they're necessary for the car to function, but none of them are actually regulating whether or not that engine is turned on and whether it's driving down the road or whether it's going fast or whether it's braking. What's actually regulating the system? And in this case, what's regulating the system is the person sitting inside, who's what they're doing with the ignition switch and the accelerator pedal and the brake pedal, right? So the same is true in the human body. There's lots and lots of parts to the system that are to some degree necessary for things to function. However, what's really the most upstream thing that is regulating, deciding, so to speak, whether to express high energy levels or chronic fatigue? And it wasn't really until Robert Naviaux's work and the cell danger response that I think any kind of coherent synthesis of what is regulating human energy levels could even be discussed. But his work really revolutionized our understanding of mitochondria, because we are all taught about mitochondria as these sort of mindless energy generators. They're just like one of many organelles in the cell. You know, we're taught in our college and high school biology classes. It's like, you know, over here's the lysosome, and here's the Golgi apparatus, and here's the endoplasmic reticulum, and here's a mitochondria. And what you need to know about the mitochondria is that it's the powerhouse of the cell. And over here's the nucleus, and you know, and that's how mitochondria are taught. And basically all anybody knows is they're the powerhouse of the cell, and they're taught about as if they're these sort of mindless energy generators that just take in carbs and fats and pump out ATP, pump out energy. But the truth is that they are actually environmental sensors. They're exquisitely sensitive environmental sensors, basically like the canaries in the coal mine. And they are constantly taking samples of what's going on in the cell and in the body, and asking the question, is it safe to produce energy? And they are sampling that environment and picking up on signals, and they can detect virtually any type of threat or danger signals you can think up, from poor, psychological stress to environmental toxicants, to poor sleep, to poor nutrition, to a huge variety of other potential stressors, respiratory infections and physical overtraining, and you name it, right? They can sense any of those things. Not because they have receptors for each of those types of stressors, but because pretty much all of those type of stressors boil down to one of a few things, boil down to either increased oxidative stress, reactive oxygen species, or increased inflammatory cytokines, or cellular damage, and then the contents of the cell, the energy molecules and mitochondrial DNA and things like that leaking out of the cell. And there are receptors to sense those things when they leak out of the cell, and that's a sign that the body is under attack. So anything that causes one of those three mechanisms to take place, which is basically every type of stressor imaginable, can ultimately be sensed by the mitochondria. And to the degree that they are sensing that, they are turning down the dial on energy production and shifting resources towards cellular defense. So basically, the mitochondria have two functions: to produce energy and to act as the hub of the wheel of metabolism, to coordinate defense responses and shut down energy production when they're detecting threats. So ultimately, in the big picture level, as far as our subjective experience of life and our energy levels, to the extent your body is under threat, it will downregulate energy levels. And our energy is ultimately a reflection of the degree to which our mitochondria are sensing threats.
That was an incredible explanation. Thank you very much. You've been definitely doing your homework, my friend. Amazing. You brought up so many good points. The thing that I want to go into is because the purpose of these master classes is to really sharpen the tools of the clinicians who will be listening to this. Would you say it's fair to state that almost every chronic degenerative problem is a mitochondrial problem? The things that most people are dealing with are likely, if not source origin, very strongly implicated in mitochondrial dysfunction?
As a generalization, yes. The very
Yes.
short version is yes. Fatigue is an interesting symptom because fatigue will almost always come first before the sort of more overt appearance of some kind of disease. Um, and, what's interesting is over the last 10, 15 years, a huge body of literature has emerged around mitochondrial function, mitochondrial health, and a huge variety of diseases. I mean, it's to the point now where you go to PubMed or Google Scholar and you look up almost any disease you can think up and mitochondria, and you will find a whole bunch of studies linking mitochondrial dysfunction to that disease, whether it's dementia, neurodegenerative diseases, or autoimmune diseases, or cancers, heart disease. I mean, you name it. And there's a whole bunch of literature on how mitochondrial function is involved in the pathogenesis of that condition. We also know that there's a whole bunch of longevity research around mitochondria as well, and we know that mitochondrial health is directly involved with the rate of aging itself, which also hugely impacts on risk of many different degenerative diseases, which typically emerge not in youth, but in older age. So to the extent you're aging faster at a cellular level, you're going to encounter a lot of those diseases earlier in life. So there's really like three layers to this discussion of how mitochondria affect us. One is, of course, if you have a robust, healthy cellular engine, you'll produce lots of energy. You'll feel very energetic. You'll have youthful levels of energy. If you don't, you'll start to feel fatigue. If you don't, you'll start to age faster at the cellular level. And if you don't, you'll also start to greatly increase your risk of things like cancer and neurological disease and dementia and heart disease and dozens of other diseases. So yeah, there's sort of those three layers to how mitochondria affect us.
It's incredible because I remember hearing Dr. Peter Attia talk about the concept of a centenarian. And he said the difference between people who die at a normal age and centenarians are that they still die from roughly the same causes. They just generally get these conditions much later in life. So it shows you that a healthy, robust energy factory, if you will, is an incredible feather in your cap for health span, not just lifespan, healthy aging.
Yeah.
So that being said, and I know you introduced it, but maybe we can go into a little bit more of a clinical assessment. Where does mitochondrial dysfunction originate for most people nowadays? Like, what do you see in terms of all the clinical experience you've had, all the people that have gone through your program? Is there a common theme that is the impetus of generating mitochondrial dysfunction?
There are many common themes, and it differs between individuals. I wish there was an easy answer to this, but I'll give you kind of an overview of how I see things. So first of all, I want to distinguish between two demographics, and this is not black or white, but this is, kind of provides a framework. So one is debilitating ME/CFS, debilitating chronic fatigue syndrome, where people are bedridden, they can barely function, they've got post-exertional malaise, this classic diagnostic symptom of CFS, which is basically extreme fatigue, body pain, exhaustion for days after even very brief physical exertion. Really just bedridden, severe fatigue. In those cases, sometimes you will encounter people like that, and maybe they've been trying for years. They've been implementing, trying to improve their health, eating a better diet, trying to do this or that lifestyle strategy, and they're still bedridden and non-functional. In those cases, usually it's something kind of exotic. It's usually something like mold exposure in their homes, or Lyme disease, or some other kind of chronic infection, and oftentimes co-occurring, like chronic infections will take hold because of some other chronic source of immune suppression, like mold exposure in their homes for years, or chronic stress, chronic sleep deprivation driving down immune function, so that and then combined with some other trigger like Epstein-Barr virus infection or Lyme disease or whatever, COVID. And so you have those kind of exotic cases like that, and those are more complex to deal with for sure. Now, having said that, this is probably only a very small portion of the total pool of people dealing with chronic low energy levels. I mean, most adults living in the Western world are dealing with chronic low energy levels to one degree or another. And this really, energy is a spectrum. So on one end of the spectrum, you've got youthful energy. On the other end, you've got people with bedridden, chronic severe fatigue. And most people are somewhere in the middle of that. They don't have youthful energy and they're not bedridden. They can still function, but they don't have great energy levels. So what's the cause for that demographic? And in that demographic, it's really things more like chronic poor nutrition, chronic poor gut health, chronic circadian rhythm disruption, and non-optimal sleep habits, light toxicities and light deficiencies, nutrient toxicities, environmental toxicant exposures, and lack of hormetic stress. Those are some of the big ones, and chronic psychological stress as well.
It's incredible because it really is, and I understand why you prefaced it. It's really a sum of all the input variables, and they are unique to the person, unique to the situation. And the sum of all the inputs is what we see as the output, the manifestation of what that person's dealing with. And I think that's why it's so challenging for clinicians, because unless you have the ability to really go through all the inputs and understand them for what they are and how they integrate, with good intentions, you may not get somewhere, successfully treating someone. Where do you think clinicians miss the mark as a whole across all spectrums of health? Because you mentioned dealing with chronic fatigue, the standard of care isn't wonderful. So where are clinicians missing the mark? What do you think that they can bolster in terms of becoming more prepared?
Yeah, there's a lot I have to say on this. I'll try to boil it down to a few things. So let me, I mentioned early on in this interview that that conventional medicine doesn't have a whole lot to offer for people with chronic fatigue. Let me tell you some specifics on that as kind of a starting point for this discussion. There was a paper published in the American Journal of Family Physicians several years ago, and it was basically it was a review of the scientific literature, but it was really evidence-based guidelines for physicians to treat patients with fatigue. So like, here's what the evidence says about how you as the doctor should treat your patients with chronic fatigue. And this paper said a number of really interesting things. One, it gave 4 things that it was recommending for conventional doctors to use to treat their patients. One was antidepressants. One was a recommendation to do 30 minutes of walking per day. One was cognitive behavioral therapy, and one was use stimulants as needed. Okay, those are literally the only 4 treatments they were recommending. So notice they did not mention anything about nutrition. It's not even mentioned in the entire paper. Like, do you think that if a patient is chronically eating McDonald's and pizza and ice cream and French fries, that this might impact on their energy levels over time? Like, it's not even mentioned in the paper that
Might have
nutrition
a
is a
play a
factor.
slight role, just a
Yeah.
slight role.
So circadian rhythm is not mentioned. Toxicant exposure, not mentioned, right? Like, these are huge factors, obvious factors. And the other thing that the paper said was, as far as what does it recommend for testing? It recommends standard lab testing unless there is some indication to run some other tests. So like, if you suspect tuberculosis or if you suspect Epstein-Barr virus, then you run a test for those things. But otherwise, in general, people are getting standard blood testing. And they literally say in this paper, and I encourage practitioners here listening to look this paper up, it's called Fatigue and Overview. It was published in the American Journal of Family Physicians. And they said in standard blood testing among patients with chronic fatigue, only in 5% of cases do they find anything on those lab tests that can explain a cause of patients that come in with chronic fatigue. Do they find anything on the blood test that helps them orient an individualized treatment? Okay, 95% of people have nothing on their tests. So, and those 5% of cases are usually things like anemia, or they find they've got diabetes, or they find they've got hypothyroidism or something like that. But 95 out of 100 people aren't getting anything. And what those people are getting is those 4 things I mentioned before: cognitive behavioral therapy, and walking for half an hour a day, and antidepressants and stimulants. That's what conventional medicine has to offer. So if you're asking me what those practitioners are missing, how are they off the mark, right? Like, how much time do you got as far as to explain how far off the mark they are in their treatment of chronic fatigue? Okay, so that's one thing. Now, within natural health practitioners, functional medicine practitioners, as I mentioned earlier, they've been obsessed with adrenal fatigue. I don't want to get too bogged down. I mean, we can, if you want, go into that in greater depth. I'm sure some people listening to this will be triggered and will think that I don't know what I'm talking about, and really adrenal fatigue is a real thing, and I don't know, whatever. So for those people, I'm open to going down this rabbit hole if you want to do it. But for the most part, the very short version of that discussion is, after about a year of exploring that literature, I found it took me forever to actually find any studies that were relevant to this topic, because if you look up adrenal fatigue, nothing comes up. So you have to actually dig and find what are the conditions that they actually, the terms for the conditions that they actually used in the studies. And the conditions that they use that are accepted medical conditions are things like burnout syndrome, clinical burnout, stress-related exhaustion disorder, and vital exhaustion. And there's also a whole bunch of research on chronic fatigue syndrome as well. And when you look at all of that body of, and you round up all the studies, what they say about the relationship of HPA axis function and those symptoms, those chronic fatigue symptoms, is there were 59 studies, individual studies, and there were about 20 systematic reviews. So like an individual systematic review might be done on burnout syndrome and cortisol levels, or chronic fatigue syndrome and cortisol levels. So there's 20 systematic reviews, 59 individual studies. Of those 59 individual studies, 15 of them gave evidence for slightly lower cortisol on average associated with the group with chronic fatigue. Okay, so basically they're comparing a group with the chronic fatigue symptoms versus healthy controls, measuring cortisol. This is very simple. This is very science 101, right? If adrenal fatigue is real and it's the main cause of these symptoms, then of course what you're going to find is lower cortisol levels in the group with those symptoms. This is science 101 of how you validate this theory, this hypothesis. And what they found is 15 of the 59 studies gave evidence for slightly lower cortisol, still within normal range on average, not even abnormal range, but compared to healthy controls, slightly lower. 11 of those 59 studies gave evidence for the exact opposite finding, slightly higher cortisol levels in the group with chronic fatigue. And 33 of the 59 studies found no discernible difference whatsoever between people with full-blown burnout syndrome or chronic fatigue syndrome versus healthy controls with no symptoms. Okay, just imagine if you saw a body of evidence like that around diabetes, for example. Like you were looking at a particular biomarker, and half the
low insulin equals diabetes.
Yeah, a quarter of the studies said it was low incidence, low insulin levels associated with these symptoms. The other quarter said high insulin is associated with these symptoms. And then the majority of the studies, 60% of them, 50% of them said there was no relationship whatsoever. What you would do in that scenario is say, you'd throw out the biomarker. You'd say this biomarker is obviously not a valid way to explain these symptoms if there is no relationship, no clear, predictable relationship. That's exactly what the body of evidence shows with cortisol and chronic fatigue. And yet for decades, people were obsessed with that. So that's one big way that those practitioners are off the mark. I'll mention one other one, and I'm hesitant to give a 30-minute answer to this question, but I went to see a functional medicine practitioner recently. I've never seen one myself and done a workup. I actually asked around some very well-respected people. I won't mention any names here, but I asked somebody very respected who's extremely well connected among functional medicine practitioners today, and I asked her for her input of who I should go see, and she raved about this guy. So I went to go see him. I was curious just to have the experience and see what he might discover doing all of these different tests on myself that I've never done, and I wanted to have his interpretation. And I have to say, I came away really unimpressed on a number of levels. For one, I'll give one example. I said, I want to do another microbiome test as well, a second one using a different technology from another company. And I didn't know what the results would be. I've never done one of these tests. So I just wanted, I know that there's variability in these test results. And if we're going to treat something and act on something, I want to know that both tests found the same thing. Okay, well, it turns out these tests came back wildly different.
As they often do.
Yeah. So I'll give a few examples of just this one microbiome piece of what happened. So one of the tests showed very low levels of why am I spacing on the name of this bacteria right now? The one that's associated with the mucus lining. Very strong.
Akkermansia.
Thank you. Yeah, Akkermansia. So one of the tests showed low levels of Akkermansia. The other test showed high levels. One of the tests showed very low levels, like rock bottom levels of butyrate production. The other tests show and also simultaneously high levels of propionate production. The other test showed the exact opposite, that I was low in propionate and high in butyrate. And by the way, I should mention, I forgot to mention this, the samples were taken from the exact same poop sample, literally the exact poop, not just the same day, but the exact poop. Yes, yeah. So this is not variation from day to day or week to week. This is the exact same sample. And there were a number of other things like that: low lactobacilli count, high lactobacilli count, right? One test. So that in itself was, the right conclusion from that set of data is we can't act on any of those things because we don't have consistency of findings. So what should be appropriate maybe is to go do another test with maybe another respectable GI test, and then you sort of confirm, you triangulate and try to confirm what is really going on there. Another example of what happened was in the parasite testing. I came back on one test negative for blastocystis, and on the other test positive for blastocystis. Okay, now that's a protozoa. Now, what does that mean? Okay, well, he was ready to treat me for it. Okay, well, I went out and talked to a friend of mine who's a world-renowned gut health expert, Dr. Jason Harlach, who's like one of the best of the best. I mean, he's a professor in the field. He's a microbiome researcher. He runs Probiotic Advisor, which catalogs all the different probiotic strains and what the science shows that he's been useful for. I mean, he's the nerdiest of gut health nerds that you can get. Like, I mean, I'd be shocked if there was anybody more knowledgeable about the microbiome than this guy. And I asked him about this blastocystis, and he said, yeah, people used to think that you needed to treat it, and they used to think it was this pathological parasite. And now we actually know, the latest research shows that it's actually sort of what is the word that he used? It's actually like a predator in the ecosystem of the gut that hunts a lot of pathogenic organisms. It is not a pathogen itself, but it's actually something that has a positive effect
It's a
in
little
regulating that
symbiote.
ecosystem. Exactly. So,
Interesting.
so anyway, this practitioner that I saw was, first of all, he only was going to run one of those tests. So based on that data, he was going to be ready to treat me for a whole bunch of things that one test found, which probably were not even legitimate, and which we only discovered because I asked to run another test that was inconsistent with those results. Then he still wanted to treat me. He basically said, well, both tests indicate some degree of dysbiosis, mild to moderate dysbiosis, so let's treat you. And then he starts citing a study on rifaximin and how it was as how as natural herbal treatments were as effective as this antibiotic rifaximin. And I said, well, wasn't that study done for SIBO? And he's like, yeah. I'm like, okay, well, these results don't indicate that I have SIBO. We didn't even do the test, the proper testing to diagnose SIBO. So, based on a mild dysbiosis that was inconsistent, the two tests found different things that they were saying indicate mild dysbiosis, and the blastocystis, which he was saying indicates a pathogen. The other guy who actually who's an expert in the field, said it's not a pathogen and you should not treat it, right? So there's so many layers to that, of what could go wrong doing that. So a lot of I guess to boil that down, a lot of practitioners are out there using cookie cutter protocols, following cookie cutter protocols in response to lab test results. And in response to lab test results that may not even be legitimate. You would maybe discover that they're not legitimate if you split tested it and used a different technology. And lack of knowledge in this case, like he's ready to treat me for what he's presuming is a parasite infection that is actually a beneficial organism. That's not a pathogen, right? So yeah, there's a number of things going on there. I would say one other layer I want to add to this, and sorry for the long response. There's a lot I have to say in response to this question.
Sum it up at the end.
So I think with both of those examples, the conventional medical approach and how almost nothing shows up on their testing most of the time, and then functional medicine approach and how you can't trust that testing in many cases, and you don't know how accurate or valid those results are. What a lot of people are missing, I think, is you can glean so much information by not just by doing these running tests and then responding to test numbers with protocols, but looking in depth at what that person is eating and how they are living, because those are the actual levers that we're ultimately going to be pulling on. And if you learn how to, I think we need to start looking at that information in the same way we look at lab test results, where we look at lab test results and we're, oh, this is off. Okay, here's the protocol I follow. Okay, this organic acids tests indicate mitochondrial dysfunction. So let's give you some acetyl L-carnitine and CoQ10 and creatine and D-ribose. And low cortisol output, so we're going to put you on these adaptogens and so on. I think we need to do much less of that and much more of really going deep on a person's nutrition and lifestyle habits and learning how to read that data in the way we read lab test reports, and then pull on the right levers to make adjustments.
Yeah, wonderfully said. The old school symptom analysis and the understanding of what I think, and I hope everyone's gathering from this conversation, is without the right perspective, you don't necessarily know how to interpret something that is more subjective, i.e., the symptom or the presentation of the client. So you kind of throw that out and go to what we perceive as objective, a number on a paper or a piece of data, which in this case may be erroneous sometimes, or a half truth at the best of times. In my own clinical practice, I've really moved away from relying upon testing in terms of making all my decisions, because when I started to realize that the person and their story and a good health history, if they've had their tonsils out, if they've had their appendix removed at a young age, these little things start to give you clues of going, huh, they've had some immune stuff that's been here for maybe over a decade. Oh, they've had some colonic stuff that's been here before. And
Mm.
there's this natural rhythmicity of the body where you have presentation of symptoms, suppression of symptoms, because the body, with its energy availability, has a bandwidth to be able to, supersede and push out the infection if that's what's causing things. And when the person gets a little bit run down, their reserves deplete, their immune system becomes a little weakened, and that thing can show itself again.
Mhm.
And no matter how good the numbers look on the paper, if your client still feels like shit, you have not done your job. So the
Yeah.
the old school adage of spending time and listening and then knowing how to take the perspective of everything we talked about with where does cortisol fit in? Because cortisol insufficiency is not a synonym for adrenal fatigue. They're separate scenarios.
Mhm.
And knowing how to then make a decision for someone, like, where do I start with this person and how do I know this decision is going to lead to an amazing outcome? Because I'll be honest with you, I've had incredible fatigue remediation success stories by working on someone's gut and not giving them a single B vitamin complex.
Yep. Yep.
And
Exactly.
unless you understand the connection point there, you might be thinking, that doesn't make any sense because digestion has nothing to do with mitochondrial function.
Mhm.
But if you read the Saldana response, oh, it does, my friend. Oh, it
Indeed.
does.
Indeed. Yeah. Very well
Yeah.
said.
Thank you. So in your, and then I know we don't have a lot of time, but I want to kind of maybe end on how does the energy blueprint go about making a decision for someone? Where do they really start for someone who's not on the chronic fatigue bed rest state? But let's talk about someone who's been struggling for a while. For the clinicians on here who may want to add more tools to their toolbox, what would you encourage them to start scanning if they're not going to go down the route of testing and rely on the data as much?
Yeah. So you need a comprehensive data set around your patient's lifestyle habits. You need to go deep on nutrition. You need to go deep on the factors that relate to gut health. You need to go deep on psychological stuff, that's emotional stuff, spiritual stuff that's going on, not just chronic stress, but what's their purpose in life? Are they enjoying their life? Are they happy? Do they wake up with a sense of purpose and meaning and excitement about their day? Because that's often a factor for people. It's kind of cliche, but it's real. And um, what are their light exposure habits, not just as they relate to circadian rhythm, um, not just vitamin D, but we get a lot of different aspects, a lot of different wavelengths from the sun, and we need to look at those wavelengths in the same way we look at nutrients from our diet. And just the same way it's possible, if you have deficiencies in certain nutrients, you have malnutrition. The same is true with light exposure. Our body requires certain intake of light nutrients every day. And if we don't get adequate amounts, we have malillumination. And that is toxic to the body. And we can also have, of course, light excesses, as we often have with artificial light exposure at night and circadian rhythm disruption. Um, Environmental toxicant exposure. You need to have a way of assessing that. You need to have a way um, of digging into circadian rhythm and sleep habits. I mean, what biomarker, what test is going to show you, oh, this person's circadian rhythm is off? It doesn't work like that. There's no test for it. You have to actually dig into their circadian rhythm habits to uncover that. Then you need to also look into their hormetic stress exposure habits as well. So we need to round up all of those different things and look at that whole data set. Now, let me expand this discussion a bit bigger for a second. So the way that I look at it is there's two fundamental contributors to one's energy levels. One is the summation of all of those different stressors I just mentioned: environmental toxicants and nutritions and light and gut health and hormetic stress, psychological and emotional stuff, right? What is the summation, the total body stress load from all of those sources? And that is going to then feed into your mitochondria and be sensed by them. And they're going to determine, based on all of those signals, whether your body can handle that stress load or whether it's exceeding your capacity. And if it's exceeding the capacity of the mitochondria to handle that, it's going to go into cell danger response, and it's going to turn down energy production and shift resources towards cellular defense. Okay, so first you need to evaluate all those different triggers and whether your mitochondria are in energy mode or defense mode. Now,
And if I could say something to that, no
yeah,
matter what you do to try to push increase energy output in that state, you will do the opposite.
right, right. So the second big piece of this, and this is going back to the previous question about holes in people's games, so to speak, particularly among functional medicine practitioners, most people do not get this next part. And it is, what's the right way of explaining it? Practitioners often operate with the assumption that like mitochondria are mitochondria. They're just there and they're doing this job. Okay, maybe they even understand the cell danger response and that these stressors can shut down the mitochondria. We need to get the mitochondria out of stress mode. Most practitioners their understanding of mitochondria is like, oh, your mitochondria are dysfunctional, so let's do the mitochondria protocol. Let's give the acetyl-carnitine, D-ribose, alpha-lipoic acid, CoQ10, yada, 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 B vitamins. And that's what your mitochondria need. Okay, they just need that support, and then they'll start to turn back on. Okay, well, it doesn't work like that. And here's the piece that they're missing. First layer is whether your mitochondria are in energy mode or defense mode as a function of total body stress load. Second layer is what is the actual status of your mitochondria in your cells, meaning you can have cells that have very small, very weak, shriveled, damaged mitochondria and very few of them, or you can have cells filled with tons of big, strong, healthy mitochondria. Okay, literally the difference between 2,000 mitochondria per cell or 500 mitochondria per cell. Okay, as an average. Now, those numbers are not pulled out of thin air, and here's why. We actually have research. This is research generally from muscle biopsy data. They stick a big hollow needle in people's quadricep, they pull out a chunk of muscle tissue, they stick it under a microscope, and they literally count the mitochondria in those cells. And they also do functional capacity testing to see how much energy those mitochondria can produce. And here's what we know from that body of evidence. People lose on average 10% of their mitochondrial capacity with age. Now, that might not sound like that much, but what it means is the average 70-year-old has lost 75% of their mitochondrial capacity. Okay, and two things happen. One, they lose 50% of their mitochondria as they get older, and the mitochondria that are present have only 50% of the energy producing capacity as youthful mitochondria. Now, here's the cool part. That is actually not a normal, natural product of the aging process per se. It is actually the product of modern lifestyles, and it is specifically the product of lack of hormetic stress in our lifestyle. And the reason we know that is because when we look at 70-year-olds who are lifelong athletes and exercisers, they have the same mitochondrial capacity as a young adult. They don't lose 75% of their mitochondrial capacity. Now, this is a huge, huge factor. This is like going from your Camaro engine in, the race car Camaro that you drive, Roland, to a lawnmower engine in your cells.
Wouldn't be
Okay.
very fast.
Yes,
I
it's
get great
not.
gas mileage. That's about it.
It's not very fast. Okay. So we have to understand that if you put a bunch of B vitamins and acetyl L-carnitine and alpha lipoic acid into the lawnmower engine, it won't make it into the Camaro engine. It's
No.
still a small, weak engine. It might function a bit better than it would
Yeah.
without those nutrients, particularly if you have poor diet and you've got nutrient deficiencies that you're correcting. It's certainly going to function a bit better, but it doesn't physically rebuild the cellular engine itself. And so the goal in this context is actually to rebuild the physical structure of your cellular engines through stimulating mitochondrial biogenesis, mitochondrial growth, and the creation of more mitochondria from scratch. And we do that through hormetic stress. And to tie that back into the original part of this discussion around the cell danger response, our what I call the resilience threshold, which is our body's capacity to handle a certain stress load and maintain health and homeostasis and high energy levels, is directly dependent on whether we've got a big, robust cellular engine, mitochondrial network, or a very weak one. And if you've got a weak one, if you've lost a lot of your mitochondrial capacity, you will be much more easily overwhelmed by the stressors of life, by your total body stress load, allostatic load, and they will be pushed into the cell danger response, and you will be pushed into fatigue much more easily. So the hormetic stress component and building up that cellular engine is literally building up our capacity to handle stress at the cellular level. This is resilience, not as a psychological concept, but resilience as a physiological cellular resilience. What is your body's capacity to handle psychological stress and sleep deprivation and exercise and exposure to toxicants and all the sources of stress in the modern lifestyle while still having high energy levels? And that is largely a function of how big your cellular engine is.
Which is so wonderful to round out, because it really is a practical takeaway. It's like, if something is in the way, the body, for me, I look at the body as kind of four states. Something that's there that shouldn't be there, it's going to cause a problem. Something that isn't there that needs to be there, it's going to cause a problem. You have too much of something, it's going to cause a problem. You have a deficiency of something, cause a problem. We like frameworks. It's a very simple thing.
Mm-hmm.
Regenerating mitochondrial capacity as a concept is actually encouraging, because to some degree you can get back some of what you've lost, providing you don't overburden your system and place more obstacles in the way that you have to hurdle to find your new homeostasis, your new set point. But when approaching this from a practical perspective, it sounds like what you're saying is, if there's a major red flag, you got to get that out of the way, be it an infection, a toxic exposure, a lifestyle stress, what have you. But from that point moving forwards, all the variables of input, from diet, from lifestyle, from strategic supplementation, from exercise, all of these things, they all have to be idealized and optimized for that person. And then from there, you have to keep walking that line of regular hormetic stress without going over the edge. And you just keep doing that until you don't want to do it anymore and you call it quits this lifetime.
Exactly. And I will add, like, we also need to understand the body is highly, highly dynamic. It is this static machine that just exists regardless of what we're doing with it. The way to see this, what's going on with your mitochondria and how dynamic they are, to help people understand what I mean by this. If you've ever broken a bone, you've broken an arm or a leg, and I broke far too many bones in my lifetime, so I've been through this experience many times. But you let's say you break a leg, you get a cast on, and you wear it for 6 or 8 weeks. Then you go to the doctor 8 weeks later, they saw off your cast. There's two things that you immediately notice. One is your leg is unusually pale and hairy and gross. Okay. And
Really skinny.
I don't know why it gets extra hairy. Don't have an
Yeah.
explanation for that. But more importantly, it's half the size of the other one. And that's because the muscle atrophies. Okay. And the reason it atrophies is because the body is ruthless about getting rid of anything that isn't necessary for survival, and especially energetically costly tissue, which muscle is, which mitochondria is.
Well, for those listening, I think Ari's Wi-Fi may have disagreed with us for the moment. I hope you really enjoyed that conversation. Or if you can hear me, I'm going to round this one out because we have hit our hour. I know you and I just kind of got into our stride. And if there are requests for the audience, we can get you back on for another episode. That was incredible. That was such an amazing conversation. Thoroughly enjoyed diving deep into those things, hearing some hard truths, and hopefully it stimulates people to really double down on understanding the concept of perspective and understanding the interplay between mitochondria, health, and all the different things that come together that ultimately end up in the client and what they're presenting. So in that context, I want to thank everyone. Ari, are you still here with us? Are you able to jump in quickly? Well, on that note, I'm going to say thank you very much, good sir. Thank you to all the audience that tuned in. So if there's any choppiness to the internet, and we'll have to have Ari back on because I think there's a lot more that we can dive into. Until next month, guys, take care.
Thanks so much for having me, Olin.
We can hear you. My pleasure, buddy. Thank you very much again. All the best. Talk to you soon.